Two F-117 Nighthawks are approaching their target over Baghdad, gliding silently below the cloud cover. Radar-guided surface-to-air missiles scan the skies, seeing little more than a faint blip that fades into the background noise. The payload bays open, revealing two GPS-guided bombs destined for Saddam Hussein's presumed location. This simple act may have revealed the stealthy aircraft to radar below, but it was a risk worth taking. The F-117's exterior was molded by precise mathematical equations, designed to disperse and absorb electromagnetic energy. With the bombs delivered and their location potentially compromised, the defenseless planes quickly turned to escape enemy airspace. This highly specialized aircraft, designed to carry just two bombs, relied entirely on stealth to get behind enemy lines and strike without being seen. It did this time and time again during the Gulf War, striking 1,600 high-value targets without losing a single aircraft. This is the story of the engineering marvel that is the F-117 Nighthawk. The F-117 Nighthawk's journey began at the desk of Ben Rich, the newly appointed director of Lockheed's Skunk Works. Taking over from the legendary Kelly Johnson, Rich had a Russian scientific paper translated by the Air Force's Foreign Technology Division. This paper held the key to a new generation of aircraft. War is an ever-evolving game of cat and mouse, and in the past decade, aircraft had switched roles from predator to prey. The development of Soviet radar-guided missiles had caught the U.S. industrial machine by surprise, resulting in the loss of 109 Israeli planes during the Yom Kippur War of 1973, shot down by Soviet-supplied surface-to-air missiles. These systems were cheaper and required less training than piloting a fighter jet, shifting the balance of power towards the Soviets. Faced with the grim reality that Soviet missiles could potentially wipe out the U.S. Air Force in just 17 days, two strategies emerged. The conventional approach focused on designing aircraft capable of hugging the terrain, flying low to avoid radar detection. This resulted in the B-1 Lancer, a variable sweep-wing bomber designed for low-altitude flight. However, a brilliant scientist named Dennis Overhauser presented a radical alternative. He placed a long, technical Russian document on Rich's desk, full of complex equations and theories. This document held the key to a new method of designing aircraft, one that could evade radar detection through the diffraction of electromagnetic waves. Turning this revolutionary concept into a functional aircraft was a monumental task. The initial design, dubbed the Hopeless Diamond, was a simple shape that many doubted would ever fly. The design was a template that needed to be carefully molded by the best aerodynamicists, propulsion engineers, structural engineers, and radar specialists that Skunk Works had to offer. This process began with the creation of a computer program called Echo 1, which allowed the team to analyze simple shapes for their radar cross-section properties. This program provided the foundation for the F-117's unique design. The F-117's design was a series of compromises and innovations. Its exterior was composed of flat, faceted surfaces, each precisely angled to deflect radar waves away from the source. This design minimized the aircraft's radar signature, making it nearly invisible to enemy radar. The engines were another critical component. To maintain stealth, the F-117 used General Electric F-404 engines from the FA-18 Hornet, chosen for their reliability and maintainability. The engine inlets were covered with radar-reflecting grids, preventing radar waves from bouncing around inside and revealing the plane's location. The entire aircraft was covered in radar-absorbing material, further reducing its detectability. Creating a stealth aircraft presented unique challenges. The engine inlets, covered with a radar-reflecting grid, had to maintain pressure recovery to ensure the engines received enough air. This grid also required anti-icing equipment to prevent ice buildup, which could block airflow and reduce engine performance. The exhaust outlets were designed to minimize the aircraft's heat signature, featuring a flat rectangular duct that spread the exhaust over a wider area, allowing it to mix with ambient air and cool down faster. These design elements ensured the F-117 remained undetected by both radar and infrared-guided systems. Despite these innovations, the F-117 faced stability issues. The plane's extreme wing sweep, necessary for stealth, reduced lift and caused aerodynamic flutter. The engineers addressed these challenges by increasing the wing area and adding large elevons for better control. The F-117's design was a delicate balance between stealth and aerodynamics, resulting in an aircraft that was subsonic, defenseless against aerial threats, and entirely reliant on its ability to remain unseen. The F-117's mission profile was highly specialized. It carried only 2 bombs in its internal bays, relying on precision-guided munitions to strike high-value targets. Its sensors and targeting systems were state-of-the-art, capable of guiding bombs with extreme accuracy. However, the F-117 was entirely defenseless against enemy fighters and anti-aircraft systems. Its subsonic speed and lack of afterburners limited its performance, but these sacrifices were necessary to maintain its stealth capabilities. The plane's range of 1,720 kilometers required frequent aerial refueling, further complicating its deployment. During Operation Desert Storm, the F-117 proved its worth. Based in Saudi Arabia, 36 F-117s flew over heavily contested airspace, striking 26 high-value targets on the first night of their deployment. The aircraft operated with impunity, demonstrating the effectiveness of stealth technology. Not a single F-117 was lost during the conflict, underscoring the aircraft's ability to evade detection and deliver precision strikes. The F-117 was a groundbreaking aircraft, but its success marked the beginning of a new era in aviation. As its existence became known, adversaries began developing counter-strategies and technologies. The F-22 Raptor, developed with advanced stealth features and the capability to engage in aerial combat, represented the next step in this evolution. The F-35 Lightning II introduced a new doctrine of interconnected battlefield information, with stealth aircraft sharing data in real time to enhance situational awareness and strike capabilities. Stealth technology has now become a standard expectation in modern military aircraft, enabling forces to strike before being seen. The F-117's legacy lives on in these advanced aircraft, which continue to push the boundaries of what is possible in aviation. The lessons learned from the F-117's development and deployment have shaped the future of military aviation, ensuring that stealth remains a critical component of air superiority. Modern warfare has evolved, and so have the challenges faced by stealth aircraft. Adversaries have developed more sophisticated radar and anti-aircraft systems, making it increasingly difficult for stealth planes to remain undetected. Mission planning now involves intricate knowledge of enemy radar positions and types, requiring constant adaptation to avoid detection. The tactics used to shoot down the F-117 over Serbia in 1999, involving moving radar and missile launchers, are examples of how stealth can be countered. These evolving threats have led to the development of new technologies and strategies to maintain the advantage of stealth. The key to maintaining air superiority lies in continuous innovation and adaptation. The integration of artificial intelligence and machine learning in mission planning, real-time data sharing between aircraft, and the development of countermeasures to advanced radar systems are just a few of the ways militaries are ensuring that stealth technology remains effective. The future of stealth is not just about being invisible to radar, but also about being unpredictable and adaptable in the face of evolving threats. The F-117 Nighthawk was a marvel of engineering, a testament to the ingenuity and dedication of the team at Lockheed Skunk Works. Its unique design and revolutionary stealth capabilities changed the course of military aviation, proving that invisibility was possible. While the F-117 is no longer in active service, its impact on aviation and its role in shaping the future of air combat will never be forgotten. Thank you for watching this deep dive into the engineering of the F-117 Nighthawk. If you enjoyed this video, please like and subscribe to our channel for more in-depth analyses of military technology and history.